The F-22 Raptor is one of the most advanced fighter aircraft ever built. Designed for speed, stealth, maneuverability, and dominance in aerial combat, it represents a major achievement in aerospace engineering and applied physics. Its design combines aerodynamics, propulsion, materials science, and control systems to create a fighter that can outfly, outmaneuver, and often outmatch almost any aircraft in the sky. In this video, we'll explore how the F-22 works, why it is so effective, and the physics behind its incredible performance. The F-22 was developed during the Cold War and late 20th century, when military planners recognized the need for an air superiority fighter that could defeat advanced Soviet aircraft. The result was a highly ambitious program combining stealth technology, advanced avionics, and supercruise capability, the ability to fly at supersonic speeds without afterburners. Lockheed Martin led the design, while Boeing and Pratt & Whitney contributed key systems. The aircraft entered service in the early 2000s and quickly became the benchmark for modern fighter design. One of the F-22's defining features is stealth. Stealth is not invisibility. It is the science of reducing the aircraft's radar cross-section, or how much radar energy it reflects back to an enemy radar system. The F-22 achieves this through its angular shaping, internal weapons bays, special coatings, and careful management of heat emissions. Its surfaces are designed so radar waves are deflected away from the source instead of bouncing directly back. This makes it much harder to detect, track, and target. Stealth is a perfect example of applied wave physics. By controlling reflection, absorption, and scattering, engineers can dramatically reduce detectability. The F-22 is not only stealthy, it is also extremely agile. Its aerodynamic design allows it to generate high lift while maintaining control at both subsonic and supersonic speeds. The aircraft uses a combination of thrust vectoring and advanced flight control computers to achieve extreme maneuverability. Thrust vectoring means the engine nozzles can redirect the exhaust flow, helping the aircraft change direction, even when traditional aerodynamic surfaces alone would not be enough. This gives the F-22 a major advantage in close-range air combat, where rapid pitch, roll, and yaw control can determine survival. The F-22 is powered by two Pratt & Whitney F-119 engines, which provide enormous thrust. A key feature of this power plant is Supercruise, the ability to sustain supersonic flight without using afterburners. Normally, aircraft rely on afterburners to exceed Mach 1, but afterburners consume fuel extremely quickly. Supercruise allows the F-22 to fly fast while preserving range and reducing infrared signature. This is important because it improves both endurance and survivability. From a physics standpoint, the F-22's propulsion system is a masterpiece of thermodynamics, fluid dynamics, and energy conversion. Modern fighter jets are often unstable by design, and the F-22 is no exception. This may sound like a flaw, but in aeronautics it is actually an advantage. A slightly unstable aircraft can respond more quickly to pilot inputs, making it more maneuverable. To keep it controllable, the F-22 uses advanced fly-by-wire systems. These computers process pilot commands thousands of times per second, adjusting control surfaces automatically. This allows the pilot to focus on tactics, while the aircraft constantly maintains stability and performance. In many ways, the F-22 is a flying example of real-time control theory in action. Although the F-22 is built for air dominance, it also carries a powerful weapons load. Its internal weapons bays preserve stealth while housing advanced missiles such as the AIM-120, AMRAM, and AIM-9 Sidewinder. It also includes a 20mm cannon for close-range engagements. By keeping weapons inside the fuselage, the aircraft avoids the radar penalties of external payloads. This is another example of smart engineering. The F-22 balances lethality, stealth, and aerodynamic efficiency in one design. Its sensors and avionics also allow it to detect and engage threats before they are aware of its presence. The F-22 is more than a fast aircraft. It is an airborne information platform. Its radar, electronic warfare systems, and communication equipment work together to give the pilot a complete picture of the battlefield. This is known as sensor fusion. Instead of receiving separate streams of data, the pilot sees integrated information that is easier to interpret and act on. This reduces reaction time and improves situational awareness. In modern air combat, knowing where the enemy is can be just as important as having superior speed or firepower. The F-22, pushes the limits of what is physically possible in aviation, but those limits come with trade-offs. Stealth materials require careful maintenance. High-performance engines are expensive to operate. Complex avionics demand significant logistic support. And despite its incredible abilities, the aircraft must still obey the laws of physics. Drag, lift, thrust, heat, and structural stress all remain critical constraints. The F-22 succeeds because engineers optimize these competing demands better than almost anyone before them. The F-22 is important not just as a weapon system, but as an engineering milestone. It demonstrates how advanced physics can be turned into practical performance. Every part of the aircraft, from its radar-absorbing shape to its engine nozzles and flight computers, is the result of scientific problem-solving. The F-22 also influenced later aircraft design, including the F-35 and future fighter concepts. Even years after its introduction, it remains a symbol of technological superiority in aerospace engineering. The F-22 Raptor is more than a fighter jet. It is a carefully engineered machine that applies the principles of physics at the highest level. Its stealth, maneuverability, speed, and intelligence make it one of the most formidable aircraft ever created. By studying the F-22, we see how aerodynamics, propulsion, control systems, and wave physics come together in a single extraordinary aircraft. The Raptor is a reminder that when science and engineering are combined with precision, the results can redefine what is possible in flight.